The last thing we need to talk about in section 5 is electrocardiography, so also represented as ECG or EKG. And an EKG is a really powerful tool used to detect the electrical currents that are being generated by the heart. What it produces on a graph is referred to as an electrocardiogram, and it's a complete recording of all the heart's action potentials at a given time, so not just a single one. And this is achieved by placing electrodes at various locations on the body to measure voltage differences. So the standard is really a 12-lead EKG, and it's going to help provide a comprehensive view of the heart's electrical activity that's frequently used in clinical settings. If you do an EKG in lab, we don't have the 12-lead EKGs. Instead, you'll be using a 3-lead EKG. So an EKG tracing is made up of several key components. You should recognize what all of these mean, so maybe make flashcards. The P wave is going to represent the depolarization of the SA node and the atria, marking the beginning of the heartbeat. The QRS complex is associated with ventricular depolarization, which triggers contraction, but it's also going to include atrial repolarization, even though it's masked by the stronger ventricular signal. So when you see the QRS complex, that's the electrical event of ventricular depolarization, just know that atrial repolarization is occurring at the same time. You just can't see it. And then we have the T wave that follows, and this is representing ventricular repolarization as those ventricles prepare for the next beat. Other important intervals are going to include the PR interval. So this is going to span from the start of atrial excitation to the beginning of ventricular excitation. It's really essential for proper timing. The ST segment is going to represent a period where the entire ventricular myocardium is depolarized, and it's particularly important for diagnosing ischemia and heart attacks. The QT interval is going to extend from the start of ventricular depolarization to the end of repolarization. And if we have any abnormalities here, it can signal for risks of arrhythmias. So one interesting fact is that the EKG not only helps diagnose heart rhythm problems and damage from previous heart attacks, but it can also detect electrolyte imbalances, drug effects, and even lung diseases indirectly. So this is an image showing you what we were just talking about on an EKG and showing you what's going on in the heart itself. So for example, here's our P wave, which represents atrial depolarization, and you can see our atria actually depolarizing right here. So the signal initiates at the SA node right here. And we're going to have this wave of depolarization throughout the wall of the right atria, and it's also going to spread to the wall of the left atria. So this is just showing you what's going on. One thing I want you to keep in mind is that we see the electrical event like the P wave, which represents atrial depolarization, but the mechanical event actually comes directly after we see the electrical event. So we have atrial depolarization, which represents contraction of the atria. So we see the P wave. As soon as the P wave is over, right here, that's when the atria contract. So when we see ventricular depolarization in the QRS complex, the mechanical event comes directly after the mechanical event. The mechanical event comes directly after the electrical event. So we see the QR complex here. As soon as the QR complex is over right here, that's when our ventricles contract. The T wave represents ventricular repolarization, so ventricular relaxation. We see the electrical event of ventricular repolarization represented by the T wave. As soon as the T wave is over, that's when our ventricles relax. So mechanical events are going to come directly after we see the electrical event on the EKG. The other thing I want you to kind of take a look at are some abnormalities. You don't need to know what the key what the EKGs look like visually, but you should understand if something's wrong with the EKG, what that represents. So this is our normal sinus rhythm. We can see a P wave right here, then the QRS complex, then a T wave, then another P wave, QRS, T wave, just like we would expect. In the event that something is wrong with our SA node and it's not spontaneously depolarizing like it should, then all we're going to have are signals being sent from our AV node. So when we send a signal from our SA node to our AV node, that represents and marks atrial repolarization. So if we can't repolarize our atria, we are not going to have a P wave. So our P waves are going to be absent. So that's junctional rhythm. So if we look at this, we can see a QRS complex and a T wave, a QRS complex and a T wave, and we don't see any P wave. So the P wave should be here. So if we don't see a P wave, that means there's something wrong with our SA node because it's not sending the signal to the AV node to allow for atrial depolarization, which is what the P wave represents. The other thing that we can have is second degree heart block. So we're still sending signals from our SA node to our AV node, but our AV node isn't sending all the signals beyond that. So we still see our normal P wave, but we're not going to see as many QRS complexes because we're not generating the signal from our AV node down to our ventricles. So what we see here is we can see a P wave, a QRS complex, and a T wave just like normal. But then we see a P wave because our SA node is still sending the impulse to the AV node, but our AV node is not sending the signal to our ventricles. So because of that, we see another P wave from our SA node sending the signal to the AV node. And then this time we actually got the signal down to our ventricles. So that's why we see ventricular depolarization represented by the QRS complex. So if we see more P waves than QRS complexes, then we have second degree heart block as represented here. The other thing we can see is complete chaos in our EKG, where it's really just deorganized. We can't see any clear P waves, QRS complexes, or T waves at all. So our action potentials are really occurring randomly throughout the ventricles. So this is ventricular fibrillation when we see this disorganization. So sometimes you can actually do an electrical shock to the heart in order to reset the normal sinus rhythm. So that's why it's called defibrillation when you shock the heart in the event that you have fibrillation.